Welcome to Math Minders Academy. In this video, we are going to look at number and numeration. Still on number basis, we have produced some videos to cover basic operations on number basis. If you have not watched these videos, we are going to drop the link on the video description so you can go check them out. But today we are going to look at conversion of numbers from one base to another. The topic we have here is actually screenshot from WAEC syllabus. So the number and numeration is the bold theme, and the subtopic is number basis. And under the content, we are looking at conversion of numbers from one base to another. So what we'll be looking at today will be conversion to base 10. We'll look at that. And then we are going to look at conversion back from base 10 to any other base. And then we're also going to look at when letters are involved. Sometimes letters are used to represent an unknown base. How do we handle such questions? And if letters are also used to represent a missing digit in a number system, how do we also find such a letter? This will be explored in this video. So we want to proceed now to look at some questions carefully selected to cover up this aspect of the syllabus. So we'll move straight to look at those questions. So here we have conversion from one base to base 10. So we are going to look at how to convert from one base to base 10. Now, let's look at the first question there. We want to convert 6,5 base 8 to base 10. 6,5 base 8 to base 10. Now, we need to understand that 6,5 base 8 in an expanded form, because if we are to convert to base 10, we will use the expanded method. Now, in order for us to use the expanded method, we need to understand the place value system. Let's use base 10 number as an example to understand how to convert other bases. We want to look at base 10. Now, let's assume that we are given a number 37. Now, if you look at this number is a 2-digit number. The first number 3 occupies the tens position. The tens position. The second one is unit. Now, these tens, of course, another way of writing this is actually going to be 10 raised to power 1. The unit digit can be written as the place value of that is 10 raised to power 0. So now, in expanded form, this 37 is meant to be written as 3 tens plus 7 units, which we can write as 3 times 10 raised to power 1 plus 7 times 10 raised to power 0. And 10 raised to power 1 is 10, so 3 times 10 is 30. Whereas 10 raised to power 0 is 1. So here we have 7 times 1. So altogether, we have 30 plus 7. In expanded form, 37 is actually 30 plus 7. Now, it is this idea that we are going to use across different bases, especially when we are converting them to base 10. We are going to use the place value system to do this conversion. So now, if we look at 6,5 base 8, it means that this 6 occupies the position of 8 raised to power 1. That is the 8th position, 8 raised to power 1, whereas this 5 occupies a value of, the place value of this 5 is 8 raised to power 0. So now, in the expanded form, this is going to be 6 times 8 raised to power 1 plus 5 times 8 raised to power 0. Now, what will that give to us? Now, if we look at this, this is going to be 6 times 8, that is 48, plus 5 times 8 raised to power 0 is 1. This is 48 plus 5. And then 48 plus 5 is going to give us 53. So in base 10, 6,5 in base 8, when we convert to base 10, it's going to give us 53 base 10. Now, how do we know that this conversion is correct? We can check back. If I return back, if I convert 53 base 10 to base 8, will I still get my 6,5 back? Of course, let's look at that. If you have not watched the video where I explained in details how to convert to and fro, you can go watch the video. The link will be dropped on the video description. Now, we want to convert to base 8. I want to convert 5,3 to base 8, which is the answer we have here. This column will be for our remainder. Now, we are going to use the division method repeatedly until we get a number that is smaller than 8. That is when we are going to stop our division. When we divide 53 by 8, it gives us 6. The remainder, we have a remainder 5. Then again, we want to use 8 to divide 6, but because 6 is smaller than 8, that means 8 cannot fully go in that division. So what we are going to do now is to drop 0 here and bring down this 6 to this side. And then we will follow this arrow here from down up. Our answer, when we convert 53 base 10 to base 8, it gives us, if we move from down up, it gives us 6,5 base 8, just like we had it before. So we can see that this conversion is actually correct. So 6,5 base 8 is equivalent to 53 base 10. So we are going to proceed to question number 2. Question number 2, the base is not known. So we are looking for the base, which here is represented with the letter N. So if 126 base N is 86, find N. Let's look at how to get that. So we have 126 base N equals 86. Now, this left-hand side, we are going to convert it to base 10. Using the place value system, what we have now is 1 times the base n raised to power. How many digits are left after 1 is taken? We have 2 and 6 left, so this is going to be power 2. That's another method of getting the correct place value for those digits. Then plus, we take the next number, 2 times n. After we have taken these two, how many digits is left here? We have only 1 digit left, so this is power 1 plus 6 times n. There's no other digit left here, so this is power 0. So you can see that the powers are in descending order, 2, 1, 0. So this is equal to 86. Of course, 86 is in base 10. If a number is written without any base attached to it, it's already in base 10. So now let's clear what we have here. 1 times n squared is going to be n squared plus this is going to be 2n. Now plus this is 6 times 1. N raised to power 0 is 1. This 86. So we have n squared plus 2n plus 6 equals 86. We bring the 86 over. We have plus 6 minus 86 equals 0. So we have n squared plus 2n minus 6 minus 86 is minus 80. Now, this is a quadratic equation. We are going to solve this using factorization method. We need 2 factors of minus 80 such that their sum will give us 2, and the product of these 2 factors will give us minus 80. Of course, if we look at 10, using 8, if you look at, let's consider 8 and 10, for example. Now, we want the product to give us a negative number. We want the product of 8 and 10 to give us minus 80. And we want a situation where if we add this factor here and this factor here, we'll get 2. It means that this 8 is actually going to be negative for us to be able to achieve that. That 8 is going to be negative. So we have minus 8 here for us to be able to achieve that. So if we multiply minus 8 and 10 together, if you look at it, check. If you look at minus 8 times 10, will give us minus 80. And if we do minus 8 plus 10, that gives us 2. So the condition is satisfied. Now we factorize. We are going to have n squared plus 10n minus 8n minus 80 equals 0. So from here, n is common. We take it, then plus 10. Now between this and this, minus 8 is common. We have n minus times plus, we result to this minus here. And minus 8 times 10 is minus 80. So we bring what is common in the 2 brackets, which is n plus 10, then n minus 8 equals 0. So when we have n plus 10 equals 0, or n minus 8 equals 0. So this means that n equals minus 10 or n equals 8. Now we have 2 values for n, one negative, one positive. A base cannot be a negative number. A base remains positive. So we are going to ignore the negative value of n and we will accept only the positive. So we can now say ignore n equals minus 10. Therefore, n equals 8 is the value that we are looking for. So for question number 2, when we solve it, our answer is 8. That means 126 to base 8 will give us 86 in base 10, to give us 86 in base 10. We are going to check it. We are going to go back. We are going to convert 86 base 10 to base 8, and we'll see whether we arrive at 126. We'll check. We are going to check that now. So we want to check if we convert 126 base 8 to base 10, will it give us 86? So if you are converting to base 10, we use the expanded method. So this will be 1 times 8 raised to power what? 2 digits are left, that is raised to power 2, plus 2 times 8 raised to power 1, plus 6 times 8 raised to power 0. So this is 1 times 64 plus 2 times 8 plus 6 times 1. So we have 64 plus 16 plus 6. If we look at this, 64 plus 16 will give us 80 plus 6, that's 86. So we are correct. If we convert 126 base 8 to base 10, it gives us 86. So both the left-hand side of that equation and the right-hand side of that equation are in agreement. So the value we obtained, 8, is the correct value. Let's proceed now to question number 3. Here, we'll be looking at how to find an unknown, especially when that unknown represents one of the missing digits in a number system. This time, the system is base 5, and there's a particular digit that is missing and is being represented with a capital letter S. How can we find that? We will see the method in our next solution. Let's proceed. Now, we want to look at, we are given S3 base 5 minus 14 base 5 equals 2S base 5. Now, we are going to convert everything to base 10. All of them, each of these 3 quantities, we are going to convert to base 10. Now, using the expanded method. Now, if we take the first one, if we take this S, we are going to multiply by the base, which is 5. Of course, one number will be left, so this is power 1, plus 3 times the base. There's no other digit left, so this is power 0. Minus, open bracket here, because this is a 2-digit number. So we have 1 times 5 raised to power 1 plus 4 times 5 raised to power 0 equals, this one will give us 2 times 5 raised to power 1 plus S times 5 raised to power 0. Now, 5 raised to power 1 is 5 times S. We have 5S here. 5 raised to power 0 is 1. 1 times 3 is 3. Here is 1 times 5. We have 5 in the bracket here. 4 times 1. 5 raised to the power 0 is 1. So this is 4 times 1. We have 4. This is 2 times 5. We have 10. And here is s times 5 raised to the power 0, which is s times 1. We have s. So let's proceed. This is 5x plus 3 minus 5 plus 4 is 9 equals 10 plus s. Let's collect like terms. We have 5x minus s equals 10 plus 9 minus 3. 5s minus s is 4s. 10 plus 9 is 19 minus 3, we have 16. So we are going to divide both sides by 4. We have 16 all over 4. So when we divide, we have s equals 4. So we have found this missing number, and it's actually 4. That means this is the complete structure. This is the way this very questions supposed to be. So what we have here is meant to be, which we are also going to test to see whether that value is correct. So if s is 4, that means we are meant to have 4, 3 base 5 minus 1, 4 base 5 equals 2, 4 base 5. So we are going to test this now to see whether there is an agreement between the left-hand side and the right-hand side. We will see this check in the next solution. Let's proceed to the next solution to check whether our value of s is actually able to satisfy this equation as we have it in question number 3. So now we want to check if we pick the value of s as 4, will everything inside this enclosed bracket give us 2, 4 base 5? That's what we want to check. So we want to check with the left-hand side actually produce the right-hand side. So let's check it. Here we have, we use this, we are going to convert, we are going to look at this subtraction in base 5. So we have 4, 3 minus 1, 4 base 5. 3 minus 4 is not going to give us a whole number, so we'll come here and borrow 1. But because we are dealing with numbers in base 5, the one we are borrowing is going to be called 5, and we are left with 3 here. This is reduced by 1. So this 4, when we reduce it by 1, we are left with 3. And the quantity we borrow, when it comes over to this unit part, is going to be 5. So 5 plus 3 is 8. 8 minus 4 is 4. And we are left with 3 here. 3 minus 1 is 2. We can see that this is what we have as the quantity on the right-hand side of this equation. So we see that s equals 4 is actually correct. So we proceed to question number 4. This time we are going to solve something that is related to division, but we'll see how do we manipulate number bases when the question involves division. We'll see the solution as we proceed to question number 4. Before we proceed to this question, if you find value in this video, click the like, share this video, click the notification bell so that each time we publish a new video, you'll be among the first that we get notified. Subscribe to our channel if you have not done so that the YouTube algorithm will be able to place this video to several other students that would actually need it to prepare themselves for examinations. So let's look at question number 4. We are given y over y plus 101 equals 1 over 10010. Now, all these numbers are base 2 numbers. So we are going to carefully convert them to base 10 and get our value of y in base 10 and then convert back to base 2. So first, let us check what is 101 base 2 in base 10. We use the expanded method, that is 1 times 2. 2 numbers are left, raised to power 2, plus 0 times 2 raised to power 1 plus 1 times 2 raised to power 0. This is 1 times 4 plus 0 times 2 plus 1 times 1. And this is going to give us, if we look at this, this is 4 plus 0 plus 1, and that gives us 5. And then let's convert another one. We want to convert is 1, 1. We want to convert this to base 10. That's 1 times 2 raised to power 1 plus 1 times 2 raised to power 0. So this is going to give us 1 times 2 plus 1 times 1. This gives us 2 plus 1, and we have 3. Then the next is 10010 base 2. This is going to give us 1 times 2. We have 1, 2, 3, 4 raised to power 4 plus 0 times 2 raised to power 3 plus 0 times 2 raised to power 2 plus 1 times 2 raised to power 1 plus 0 times 2 raised to power 0. So this is 16. 1 times 16 plus 0 times any quantity is 0. 0 times any quantity is 0. 1 times 2 is 2. And 0 times any quantity is 0. So we have 16 plus 2. So this gives us 18. Okay, now what we now have here is what we are actually solving now becomes y over y plus 5 equals 3 all over 18. So this is what we are solving now. So let's proceed this way. We have y all over y plus 5 equals 1 over 6. Remember that this will reduce to 1 over 6. So we cross multiply 6y. If we use this to multiply, we now have used this to multiply here, or we are multiplying both sides by 6, so we have y plus 5. So we have 6y minus y equals 5. 5y equals 5. Of course, if you now divide by 5, what do we get? Y equals 1. Y equals 1. So we've been able to find the value of y, and this is correct value. So we have come to the end of this tutorial video. If you find this video impactful, like, share, and click the notification bell so you can always get our videos each time we publish new ones. Also, don't forget to subscribe to our channel. Go and watch basic operations on number basis. If you have not done so, we have some videos that we have released in the past that covers these areas. The link to these videos will be dropped in the video description. See you in our next video. This is Math Minders Academy. Bye for now.
In the midnight glow where the stars align, we lose ourselves in the rhythm divine. Underneath the sky painted with dreams, we're chasing the echoes of silent screams. Caught in the spell of the cosmic night, where fantasies bloom.